In this video, we take a look at the steps necessary to name an ionic compound. Now before we do that, let's determine exactly what classifies as an ionic compound. The features of an ionic compound include a cation, which is the positive ion, connected to an anion, which is your negative ion. Many students sometimes incorrectly think that an ionic compound is just simply a metal with a nonmetal. That's not entirely true. The positive ion can be a metal, but it could also be ammonium ion. So it'll be a metal or ammonium ion, which is NH4+. The anion portion would just be a nonmetal or nonmetals. And that's the real definition of an ionic compound. It's a cation connected to an anion, not necessarily a metal to a nonmetal. When it comes to naming ionic compounds, the rules are the metal is written and named first. If the metal possesses multiple charges, then we must use a Roman numeral to describe its positive charge. Remember, when it comes to metals, the transition metals tend to have multiple charges. Manganese, for example, could be +1 or +2, +3, all the way up to +7. And because of that, we'd have to use Roman numerals to describe which one of those charges we're dealing with. And for the most part, a majority of the transition metals have multiple charges. And remember, in my videos and chapter reviews, I've said that cadmium, silver, and zinc, although they're transition metals, they only have one charge, and therefore they do not use Roman numerals. Cadmium's always +2, silver's always +1, and zinc is always +2. Now, the nonmetal part of the ionic compound keeps its root name, but has its ending changed to "ide." And then if polyatomic ions are present, then they are named normally. If we take a look here, we have aluminum here with the perchlorate polyatomic ion. Now, aluminum is in group 3A. It only has one charge of +3. Therefore, it does not use Roman numerals, because we only use Roman numerals if we have multiple positive charges for the metal. So here this would just simply be aluminum perchlorate. For the next one, here we have tin with sulfide. Tin, just like lead, are both in group 4A. They both can have two possible charges. They can either be +2 or +4. Because they have more than one possible charge, they would have to use Roman numerals. And we're going to say here, when it comes to determining the charge of a metal that has multiple charges, we're always going to make it X. Then we look at the nonmetal portion. Its charge we should know. Sulfur is in group 6A, so its charge is 2 negative, or -2. Now with that information, we can solve for the charge of tin. So we'd say we have one tin, which is X, plus 2 sulfurs, each one is -2. And this equals the charge of the compound. The compound is neutral with no charge, so its charge is equal to 0. So that's X minus 4 equals 0. Add 4 to both sides, X equals +4. So that means we're dealing with tin 4 sulfide. And then finally we have calcium phosphate. Calcium is in group 2A, so it's 2+ for its charge. Phosphate is a polyatomic ion. Now, if the numbers in the charges were the same, they would cancel out. But here they're different numbers. One's a 2 and one's a 3. When the numbers themselves are different, they don't cancel out, they crisscross. So the 2 from here would come here, and the 3 from here would come here. Now that 3 comes and gives us Ca3, and that 2 is for the entire phosphate ion, so we put phosphate in parentheses, and we put the 2 there. So that'd be calcium phosphate. Now remember, these are the steps you need to take whether you're writing the formula of an ionic compound or naming an ionic compound. Fundamentally, it's just a positive ion connected to a negative ion. And remember, if the metal has multiple charges, we have to use Roman numerals. If it doesn't have multiple charges, there is no need to use Roman numerals. So remember these steps when naming any type of ionic compound.